Thank you. Yeah, I'm just going to share my screen quickly here. Okay, so my name is Anna Peterson Bauman, and I am currently the Outreach and Education Coordinator for Fond du Lac Tribal and Community College, the Environmental Institute over there. But this was my thesis work on Minnesota Lake Association efforts and water quality change over time. My advisors were Nate Johnson and Afton Clark Sather over at UMD, and Minnesota Lakes and Rivers Advocates was our community partner for this project. And so I studied lake associations, and this is an overview of some of the work that we did. There is a lot. And if you don't feel like I covered something that you're wondering about, feel free to ask about it in the chat. And afterwards, I might have looked into it. So to get started, I'd like to thank my community partner, Minnesota Lakes and Rivers, the Remote Sensing and Geospatial Analysis Laboratory at the U of M, Institute on the Environment, all the survey respondents, might have been some of you, and the DNR MPCA for data, water resources at the U of M for my degree, and then my committee members and many, many other people that helped me out with this project. So, who governs water? Everyone. It's so many people. It's the federal government, it's the state, it's local government, and also on the stewardship side of it, these non-governmental organizations such as lake associations who really take all of the requirements and suggestions of these different agencies and put them into action, either through their time or their money and their efforts. And so, why specifically lake associations? We know that they contribute a lot. They're collectively the largest conservation organization that we have in Minnesota, with over 100,000 members total. They contribute more than $6.2 million annually towards the betterment of Minnesota lakes. They contribute more than 1.2 volunteer hours annually for that purpose as well. So they contribute a whole bunch. And so they have all these big contributions, but it's really difficult to measure the environmental quality of the lake and how those actions affect it. That's kind of due to these different confounding factors that we have, whether it's where the lake is located, so their ecoregion in Minnesota, the aquatic invasive species that might be present, the size of the lake, hydrology, climate change, and there's so many others like development. And so, what my research really aimed to do was to parse some of this out and see if any of the social and actionable changes that lake associations were doing were making a difference, with all of this included. So, my goal was to assess these actions that they were participating in and then evaluate those actions with water quality. And so we'll kind of talk about both of those throughout this presentation, and hopefully it makes sense. Really tried to pare it down. So study background is it took me 2 years to complete, more like 2.5. I developed a survey that we sent out through Minnesota Lakes and Rivers Advocates. They had all of our contacts. We analyzed the survey, paired those results with water quality data, and analyzed the survey and water quality types of data together. So in order to create the survey, we had to talk to our key informants, and we did these interviews. We talked to them about different things that may matter in lake associations. These key informants were members, board members. They were people who collaborated with lake associations, scientists, researchers, but everyone had a real connection to the lake association that they were working with, and they were able to give us a lot of information. We partnered with Minnesota Lakes and Rivers Advocates that had a good idea of what changes lake associations wanted to see in lakes and what were concerning them, what they thought they were doing a really good job with. Minnesota Lakes and Rivers advocates for lake associations and lake water quality at the legislature. So they had a really good idea of what was going on the ground. We were able to create our survey, which had 7 different parts, a lot of which had part A, B, and C questions. So it ended up being about 80 questions, 52 without the parts A, B, and C. So it's a very large survey. And we were able to deploy the survey to over 500 different lake associations in Minnesota, which was great. So where did we deploy them to? All over the state. Wherever we knew of a lake association or had contact for them, we did send them the survey, except for the boundary waters. Because in the boundary waters, we don't have any lake associations, or we're not really supposed to. The boundary waters has other organizations, but we did not include any of that in our study. So the results that we got back from the survey was that 223 different lake associations responded. 137 responses were usable. That lower number is not because the other ones were bad or there was anything wrong with them necessarily, but just because our water quality data was for one lake at a time, it would be hard to pair lake associations that were coalitions of lake associations or comprised of multiple different lakes or chains of lakes. And so we took a lot of those out. Now, if a large chain of lake, like Gull, their lake association responded, then we would take all of that data and we would try to use that with the most completed survey results. So we did do a lot of like parsing out what was usable and what wasn't. 35 out of 87 Minnesota counties were represented. All 7 ecoregions had responses, but all of these were concentrated in the northern lakes and forests, the north central hardwood forest, this belt here, and then the western Poor Belt Plains. And that makes sense because that's where most of the lakes in Minnesota are located. So when we got all these survey results back, we parsed through all of them and we wanted to find questions that had high variability, because if there was no variability in the answers to the questions, there wouldn't be a difference between lakes when compared with the water quality data. So we looked for high variability, and we also looked for clues that this would lead to high levels of social capital. And what is social capital? It's basically the benefit gained from social interactions, connections, and networking. We use 2 different types of social capital to break it up. So bridging social capital, which is the connections gained outside of your normal group. So think about lake associations, maybe collaborating with the Minnesota Pollution Control Agency or the DNR or different agencies, some even the Army Corps of Engineers. Think of bonding social capital as membership and involvement within the lake association, and the capital and the benefit that comes from that. So after we analyzed all the questions, we came up with these 5 as being indicators of social capital. And so this is more of the social science side of my thesis and work. We'll get to the water quality side in a little bit. So these questions were, what is your annual budget, which is both bridging and bonding because you can get your money from lots of different places. What's the percent of members that regularly attend meetings? What's the percent of lakeshore property owners that are members of your organization? Does your lake association collaborate with outside organizations? And do you have a recruitment or outreach program currently in place? And so with these questions of social capital, we also have to include confounding factors. So coming back to this image of the different confounding factors that could be making a difference in the end water quality results that we see, we decided to use these 5. So we called them characteristics of lakes that were unrelated to social capital. And so that was percent of developed shoreline, ecoregion, so where they were located, presence of zebra mussels, how busy the lake is perceived by lake association members comparatively to lakes around them, is how the question was asked. And we used this question because we were unable to get a straight and narrow answer of how busy each lake was. Some lakes have data for how many people are visiting their landings, some don't. And so this was we were able to get a much more robust data set from this. And so it's not a hard and fast answer, is that lake busy? It's how it's perceived. And then lake area and average depth is what we used for our hydrological component. In the future, and I'll mention this later, I really wish we would have used watershed to lake area ratio, but the data wasn't necessarily available to us for our whole data set, which was thousands and thousands of lakes. So the water quality data that we used was trophic state. And we use the definition of the suitability of water for a specific use because this is the definition that EPA uses and lots of different agencies. It's very broad and it's meant to be that way, just so that you can change the water quality requirements for different uses of that water. We decided to use trophic state because trophic state is really widely available. It can be through remote sensing or ground truthing measurements. It can be used in many different settings. Trophic state is the measure of how biologically productive the lake is. So think about it kind of in green, in sensitive green. It measures the chlorophyll A, total phosphorus in the lake, and clarity, and puts them together to come up with an index unit. And we decided to use this. We did try to use some other different methods. We just weren't able to get that robust data set that we needed. We also are defining our data as the change in water quality over time. Our data set was from 1985 to 2022. It's a very long-term data set, and we'll talk about how we define that a little bit more later. So interpreting delta water quality, so interpreting our trophic state, these high trophic state index numbers are these super green lakes. Think of a lot of harmful algal blooms. And these really low numbers are super clear, low chlorophyll A, could be low nutrients, but if there are zebra mussels and other invasive species, that might be interacting with that as well. Most lakes in Minnesota kind of sit in these three, and more specifically these two, but some in the northern lakes, we have some oligotrophic lakes as well. Notice that in this section, it takes about 10 trophic state index points to move between categories. So where did our data come from? We actually were able to get remote sensing data from the Remote Sensing and Geospatial Analysis Laboratory, and this took Landsat imaging data from a satellite, and it put it through some data processing and was able to output and give us trophic state index numbers for each lake. And Leif Olmenson's lab at the University of Minnesota does a great job with this. They did the data processing, and so they did really the hard work for us, and that was really awesome to be able to get that data from him. There are some downfalls to remote sensing data. You do have to do atmospheric correction. You might have some gaps in the data where you can't be totally sure that it's correct, and it's just not quite the same as those ground measurements that you're taking. You're able to see the lake, see the water, see what's going on around it to get some context. But it was able to give us a really robust data set, and it's kind of the theme of this whole project. And so we took that water quality data and we took the average from each year and then averaged that change from 1985 to 2022. So all of the data that I have is going to be the average change per year. So summary results, and really the individual results when we paired our confounding factors, our social capital data with the water quality, were that all ecoregions, so all areas, had different speeds of improving water quality overall. None of them had, on average, declining water quality, which was great, but the north central hardwood forests had the fastest improving water quality, and the western Corn Belt Plains had the slowest improving water quality. Lakes that were considered busier by their lake association had slower improving water quality overall. And then individually, lake area mattered for how fast or slow water quality was improving. We saw on average large lakes, really large lakes were having a harder time with water quality improvement. And then no individual social capital factors were influential separately. So for our individual analysis, we didn't see any social capital factors that outweighed our confounding factors, so those environmental things that were going on. This is just a quick view into what our water quality data actually looked like. So this middle line right here is the average change in water quality per year for Minnesota lakes. You'll notice that it's a negative number, and so we have improving water quality. That's kind of calling back to that trophic state index where I said negative is better. So that's great. And then we have our lakes with the fastest improving water quality, so our top 20% over here. I know it's weird because it's negative, but this is our top, and this is our slowest improving water quality, fastest declining water quality. Sorry, it even trips me up. So our fastest declining water quality over here. So before we get into the comparative analysis where I included all of the different factors together and were able to come up with ranking of what mattered the most and what mattered the least. These are just some of the ranking questions that we asked in our survey that we didn't necessarily originally pair, but we wanted to share with lake associations. And so we asked, what was your lake used for, was the question, and to rank those. And overall, lake associations ranked it to be rapid motorboat sports, casual boating, and casual fishing was what their lakes were used most for. And you'll see in the lakes that had the fastest improving water quality and the fastest declining water quality that they were ranked the same. So that gave our lake associations a really good look at their lakes. Are all very similar. All the lakes that answered this survey look similar, and a lot of our lakes in Minnesota look very similar. So another question that we asked was what was most important to them for lake community connectedness. And so overall, aquatic invasive species education and monitoring and plant management were really important. Lakes with really fast improving water quality ranked social capital and water quality monitoring as really high, and lakes with really fast declining water quality ranked aquatic invasive species monitoring and education really high as well. When we asked what they spend the most time on, again, aquatic invasive species monitoring and management came up a lot, and water quality monitoring overall. In lakes that had fast improving water quality, plant management and aquatic invasive species management came up, and really fast declining water quality, it was those water quality improvement projects and cleanup projects that came up. And none of these are to say that if you have really fast declining water quality that you're not doing enough, because that may be due to the other confounding factors. But it's really interesting that this is how our lake associations answered overall and overwhelmingly, and it just gives maybe some ideas of what to switch up on and what to change. What did they rank as their largest environmental stressor? So that was aquatic invasive species across the board. And then overall water quality and water levels were also ranked fairly high. For lakes that had really fast improving water quality, shoreline development was also a concern. And then really fast declining water quality, climate change was also a concern. So what do lakes spend the most time on, most money on? Aquatic invasive species management, again, was ranked very highly overall, and also for lakes that have fast improving water quality. And then water quality improvement projects, water quality monitoring, cleanup projects, and outreach projects. And so when we decided to put all of the questions together, all of the social capital, all of the confounding factors, and we set them against our water quality data, we used two different analyses to do this. And that was the classification and regression tree, which was a ranking analysis, and then the multiple linear regression model, which told us what was seemingly important. And so in the multiple linear regression model, I'll talk about the card analysis in a second, but the multiple linear regression model, how big the lake was really important. And then whether or not they had aquatic invasive species, and in this case, zebra mussels, was very important as well. And then if they had a recruitment and outreach program, that was very important. And it's important to note that when we ask these questions, if we asked them, for instance, if they had a recruitment or outreach program currently in place, if they said yes, we did ask them what that was so we could share that information with the lake associations, other lake associations. And so I thought this was really interesting when I was going through and looking at our multiple linear regression. But what really stood out was this CART analysis, and it's really complicated page. And so I'm going to try my best to talk about it. But it kind of branched off into these different branches. And what it's doing is it's ranking what matters most to changes in water quality to what's mattering least. And it goes further down, but this is just those first through fourth and fifth order rankings. And so on this side over here, we have lakes that are less than 343 acres in size, so those smaller lakes, are improving in water quality by a change of 0.23 trophic state units per year. And that's 22% of the lakes in our data set fell into that category. Now, if you go down even further, so lakes less than 139 acres in size, we're improving even faster with an improvement of 0.39 TSI units per year. And that's 6% of the lakes in our data set. So area matters a lot, and that's what came out in our individual analysis and in the multiple linear regression. If you kind of move on to this big side of the equation, lakes that are larger than 343 acres in size are also improving by 0.017 TSI units per year. And that's slower, but it's still an improvement. And when you multiply any of these numbers over by 37, because it's 37 years, that change is pretty large. Now, this side of the equation is that lakes that have more or equal to 57% membership participation have a faster improvement in water quality over time. So lakes that are large with high participation are improving faster. Lakes that then fall into this category but have more developed shoreline are improving even faster. That was really interesting. That was very interesting finding for us, just because I would have originally assumed the opposite, is that we wanted less developed shoreline, or that less developed shoreline was better. And what I think we're seeing in this is that lakes that have lots of developed shoreline have lots of people and therefore have high participation. When I was looking at all of my other numbers, that really did make more sense. So that is my hypothesis. I don't know if that's completely true, but that would be what I guess. And then down here even further, it says that lake associations with a budget larger than 19,000 per year have an even faster increase in water quality. Now, I really thought that budget was going to come up faster and first. And so this was interesting and says that participation matters before budget in this case. And so for this side over here, we're kind of moving on. Lakes are still large, so lakes are still larger than 343 acres, but if they have less than 57% member participation, they are declining in water quality per year. So that's a stark difference from the other side of this. And it's saying that lakes that are large but then have low participation are actually declining in their water quality. After that, it says lakes that are larger than 700 acres in size are declining even faster. And then lakes that are ranked as really busy by their lake associations compared to those around them are declining even faster. And so really large lakes that are really busy have fast declines in water quality. And that might be what you already thought, I don't know. But that's what we found. And then lakes that are large but have high participation are still increasing their water quality, and small lakes have a really good chance at increasing their water quality. So in summary, individual factors like budget, participation, and membership don't necessarily make a large difference on their own. But membership, participation, and outreach and recruitment might be more important than budget overall. And lake size and environmental factors complicate things. No lake is the same, and it's really going to make a difference in the water quality data that we're getting and we're analyzing. And so some limitations from this survey was that the answers from the survey were from one snapshot in time. There's with any survey that we do, there's always bias in the answers. We might have had lakes that had lake associations that were really highly involved to be our participants, and maybe lakes that didn't have so much involvement didn't answer our survey. I don't know. That definitely could be happening. And then I was unable to parse out much about how the zebra mussels may be affecting the data. Nothing came up as necessarily significant, but we know that through other analysis and other work that people have done that it really does make a difference. So the implication of this is that participation really matters. Money is not everything. No single social capital indicator was necessarily influential on its own, and that people and environment interactions are incredibly complex. And so with that, if you have any questions, please let me know. This is my email, and I will leave it up here. I don't know if you want me to stop sharing my screen or whatnot, but I will
Yeah.
take any questions.
Thank you so much for your presentation, Anna. Yeah, that was great. Super awesome information. Yeah, feel free to leave up your email in case anyone wants to, um, write it down. And
Yeah,
just taking a quick look at some of the questions Pamela asked earlier. You answered it a little bit, but what made those responses unusable?
yeah. So the responses being unusable, it's not because they were bad or anything like that. It just was that it would have been like if we had a lake association that had maybe it comprised 4 or 5 different lakes with different water quality because they're separate or there's just, yeah, basically if they're separate, we wouldn't have been able to take those answers and just apply it to one. We would have had to apply it to all of them, and then it would complicate how we were able to analyze it, and it would really confound a lot of our results. And so the data that we have, all of those answers in our big sheet that we write to all these lake associations and tell them all of our results, that's going to include all of the survey results that we got, but not necessarily all of the survey results will be included in our analysis with the water quality. I don't know if that completely makes sense, but yeah. And then can we get the water quality data on our lakes? So the Minnesota Pollution Control Agency has a lot of publicly available data for a lot of different lakes, and you should be able to get some water quality data from there. The Minnesota Lake Finder is another really good place to get water quality results from your data or get data water quality results. Another really good place to look for water quality data is the Minnesota Water Atlas. And that'll give you some remote sensing data as well. And if you email me, I will be able to give you a bunch of links to where that's at. My specific data, because we are having to anonymize it with the survey, will not be publicly available in its full form, just with the anonymized data. But I would be able to share with you individually what your water quality data is, not necessarily the survey results.
Yeah, I dropped the link and then someone else also dropped the link into the
Great.
lake browser from Leaf. And someone just asked about, has anyone ever compared the volunteer SecuDist data with the satellite clarity data? How well do those align? And yes, we worked
Mhm.
with Leaf a lot in the past between our program and, kind of ground truthing the satellite clarity data
Mhm.
with the volunteer collected Seki data.
Yep.
So yeah.
So, yeah, part of Leaf's analysis and a lot of other people's analysis is whether or not this remote sensing data that we've had for a really long time matches up with the data that you all are participating in, the data collection that you all participate in, and other researchers are participating in, and found that they're very compatible. Um, there is a lot of different papers on this. Again, I can send some as well. Um,
Larry asked, oh, sorry. Oh, can
no,
you explain more about outreach and recruitment? Maybe some examples?
yeah, so different lakes have different. I was really, I really enjoyed reading what people were doing for their outreach and recruitment. And I'll make sure that Waverly gets the full report when we're doing the report to send out to all of you. But um, some lake associations put on a lot of public events where they were able to either do educational seminars or where people were able to come up and talk with them about their lake or some of the different projects that they're participating in. Some lake associations had outreach committees that went around to the different property owners on the lake and around the lake and surrounding communities to either ask them to become members or ask them what their concerns are so they're able to um, focus their lake association in more and also to recruit. And so that outreach and recruitment component really falls under education. So being able to participate in public education seminars, to have people from the DNR and collaborate with other organizations to come in and talk to your lake association or talk to community members seem to be the most effective for most of these lake associations that answered.
Do you know how many lake association groups in Douglas County were included in your study?
It was a lot. Yeah, Douglas County is one of our had one of our highest response rates, as well as some of the different coalitions of lake associations that we included in that ranking data, but not necessarily with our water quality data in our final report. I don't know an exact number. If you email me, I could for sure get you one. It was really, really high.
Hmm. Do you know much about the weed harvesting programs, or did you look into that at all?
So you're right. It is a big topic. I see that you wrote that in there. So I think weed harvesting, it's a lot of people have a lot of different opinions on whether or not it's useful and helpful. I don't know if I am qualified to speak on it. A lot of times when you do weed harvesting, it comes from a want to clean up your lakeshore or make it better for swimming or some of those recreational uses. I don't know that it's shown to be necessarily super effective in improving overall water quality.
Larry did say, he found some discrepancies between, the SECI data and on-site readings, but for
Yeah,
Hungry Jack.
that can happen, and I can also give you people to report those to, and yeah, that can definitely happen. Nobody's perfect, and citizen science is fluid. So I would just make sure that you're reporting those to people, reporting those to Waverly, maybe. I don't know.
Yeah,
Yeah.
feel free to reach out to me. You have my contact info, and I can hook you up with Leaf's lab um, to report that. Britt asked, if you were going to make a statement to help convince people to join and participate in their lake association from this data, what would it be? It's a great question.
I think because a lot of people are very worried that if they don't have a lot of money, they won't be able to make a difference. And so, what I would really encourage and do is say your time and the your ideas and your participation in this matters more than the funding that we have. And so, being able to have bodies and participate in these cleanup projects and all the different great work that lake associations do. I mean, that takes people. And to be able to do that has led to cleaner lakes over time. It's going to help with, sorry, I just saw someone's comment come up, but it's going to help with your kids being able to have cleaner water. It's going to help with being able to use these lakes for the recreation that we all enjoy. And so just don't worry necessarily about everything else, but just get out there and participate. It's being recorded, right? We can send a copy to people.
Yes, yep. I will be sending a copy of this recording out to everyone, most likely next week. And I'll include links in that email as well, the links that we discussed here. So y'all can have those links available to check out all the different data viewers that are out there.
Yeah, and I would just like to say thank you to all of you as well, because researchers like myself and my colleagues cannot do any of this work without your helping hand. So that's really, really awesome. And thank you for having me today. I will make sure to send out my copy of my final report. And also, if you have any questions, Minnesota Lakes and Rivers Advocates is really good with getting you connected to the right people as well. So, yeah.
Yeah, awesome. Well, thank you so much, Anna, for giving this presentation today. And so all of our volunteers, thanks for collecting data that helps with ground truthing, the satellite data that we use. And yeah, this was so interesting and awesome to hear about. And I'll get the recording out to everyone next week with links, emails, all of that good stuff. And thank you again.
Thank you so much, everybody. Have a great day.